All right, Pythonistas, here's lesson number 8 in our series of learning CircuitPython on the Circuit Playground Bluefruit. And in this lesson, we're going to bring on to funk. We're going to learn how to play sound off of the small speaker in our Circuit Playground Bluefruit. And we're going to have a brief introduction to functions as well. Now, the lesson I'm about to show you is based on a really wonderful lesson by John Park, who did this for the original Circuit Playground Express. I have some modifications here for the Circuit Playground Bluefruit, and I've changed at least one of the files as well. So I've put together some files that you can use as we start to play sounds and that we'll eventually use to create a drum machine. And the files that the Circuit Playground Bluefruit can play are only wave files that are in mono, not stereo, at 22 kilohertz or smaller and at 16 bits or smaller bit rates. So they're kind of tiny files here, and instead of worrying about the technical details, I've put a bunch of files together for you at this URL, bit.ly cpxb-installation-profg. And all of those letters are in lowercase. So if we hop over and type those in, and again, if it was bit.ly/cpxb-installation-profg, you will see this page. It's a Google Drive. And inside of here, I've got files that I was using for my students in class, but the files that we want are going to be in drum samples. Now you can see a bunch of files in here. I actually replaced the electric blip file that was in there with, I wanted some scratch in there for DJ work. So you can highlight and download all of these guys. To save some space, I'm not going to download the electric blip. So I'm going to Command All, or you could Command A, or you can Control A in Windows. Then I'm going to Option click, or it would be Control click in Windows to unclick the electric blip 2. Then I'm going to right click on one of the file names that I've selected. This will select all of them. And what I'm going to do is I'm going to download them, and I'm going to save those to my desktop. Now in my version of Chrome, I've configured it so that it asks me where I want to save it. If it didn't ask you where to save it, it's probably in your downloads folder. But I'm going to select mine, save it right on the desktop. And I don't need to remember the file that I've saved, but I'm going to go to the desktop. I can see a zip file. If I double click on it, that will extract it. On Windows, you can also right click, and there's something that says either uncompress or extract. And I don't need the zip file anymore, so I'm going to throw that away. And if I take a look inside of here, I've got a bunch of different files, and I want to put all of these on my Circuit Playground Bluefruit. So what I'm going to do is I'm going to grab all of these files here. I've plugged in my Circuit Playground Bluefruit. When it's plugged in, you should see CircuitPy showing up in the lower left-hand corner. I am going to select all of these files and then just drag them right into CircuitPy. That will copy them all over to my Circuit Playground Bluefruit. And I've got these wave files on there, and I'm ready to start coding. Now the code that we're going to write at first is not especially friendly, but one of the good ways to think about this is it's almost like a software Lego. So once you write the code to be able to play a file, you can reuse the code over and over again. And what I often do is just end up copying and pasting it from programs that I know work. So this way I don't have to worry about typos or anything like that. So the first thing that we're going to do is we're going to import 2 different libraries that we're going to leverage. Then you absolutely need this bit of code. And it was introduced in November 2019. Now you have to enable the speaker, which means kind of unmute the speaker so that it can play audio. And if you don't include these lines here in any code that uses the speaker, your code will still run. It looks like it's fine, but you won't hear anything coming out of the speaker. And then we're going to write a little routine down here, which will play. In this case, it'll just be our drum cowbell file. So after we do this, I'll show you how we can modify this. We'll have a couple of challenges, but let's begin here. Now I'm back in the code that I wrote earlier, and I'm not getting rid of some of the code that I've got here. I mean, you certainly could if you wanted to, but I'll be reusing some of this code at different lessons in the future. Now, when my students copied and pasted some starter code in one of their lessons, they actually had these 2 from import statements for audio. If you don't have them, go ahead and retype them in. It would just be from audio pwmio import pwm audio out as audio out. And what you want to make sure is that you've also got the case correct in here. So audio pwmio is all in lowercase. The pwma for pwma audio out is in uppercase, but the udio is in lowercase. The O is in uppercase. And then for audio out, it's upper camel case, or capital A and capital O for out in there. And then after that, you're going to have a from audio core import, and it's going to be wave file. And that wave file is with capital W and a capital F. Since I just retyped 2 lines that I already had in my code, I'm going to delete those 2 lines. Otherwise, when I run my program, I'd get an error. And now we're going to enter some code to be able to enable the speaker. That's so that we can hear things coming out of our CircuitPlayground Bluefruit. And the lines that we're going to type in are speaker. You can call it anything, but speaker is a good name for the speaker. And we'll say equals digital IO, all lowercase, dot digital in out, and that's an upper camel case with capital D, capital I, capital O, open parentheses, all lowercase, board, dot, and then all uppercase, speaker underscore enable, and then close parenthesis. And all this line says is, hey, there's a speaker on the board. Now the next line is speaker dot direction, all lowercase, equals digital IO, all lowercase, dot capital direction, dot all caps output. And what this does is it says, hey, take that speaker, and what we're expecting is to send output to it so that it can play sound. Then press enter and type this line, speaker.value equals capital T true. And those 3 lines just unmute the speaker. And after that, what we're going to do is we're going to add this little chunk of code in. I'm going to get rid of our while true loop. So right now we're going to not have any loop that's running infinitely. We're just going to play one sound. Now there's a lot of code that we're going to type in. And frankly, at this stage in your programming career, you don't have to know what all these lines are. So what I'm going to do is I'm going to type them in quickly. I'll read them back to you. You want to make sure though that you've typed things in exactly as they are on the screen here. So that's with the same amount of spaces, with the correct uppercase or lowercase letters. Make sure whenever you start a parenthesis that you close it in a parenthesis. When you start a double quote, you close it in a double quote. So the first line is wave underscore file equals open parentheses, double quote drum underscore cowbell dot WAV, close double quote, comma, and make a space, open double quote RB, close double quote, and then close parenthesis. Now, if you're curious what this does, the open command says open a file. We pass in the file name, drum cowbell wave. The RB says read it in as binary, just ones and zeros. And we put that in a variable that we call wave underscore file. So essentially, this is just read the stuff off a disk, and we're going to call that wave underscore file. Now, the next line is with in lowercase, space, wave file, that's one word with a capital W and a capital F, then open parentheses, and then what we're putting inside the parentheses is wave underscore file in lowercase. That's that variable we just created. Close parentheses, and then put in as, and then wave, and then end it with a colon. Now what this next line does, if you're curious, is the capital wave capital file takes the contents of drum cowbell, which we called wave underscore file, it converts that into a wave file that we can use and we can play back, and it calls it lowercase wave, W-A-V-E. Now when you press enter after the colon, it's going to indent, and we're going to write another with statement. And this with statement is going to take capital audio, capital out as one word, and then inside of the parentheses, we've got board, dot, and then in all caps, speaker. Then after the closing parentheses, we have as, audio, and then a colon. Now, if you're curious what this line does, is it uses the audio out command to tell our Python code that, hey, we've got a speaker attached to our CPB board, and we're going to call the speaker audio. So now we've got a file called wave, that's a wave file, and we've got our speaker that's called audio. Press enter after the colon, we'll indent again, and by typing audio.play, we're saying take that speaker called audio and play, and then in parentheses, we've got wave, which is the name of our wave file. Press enter again, we don't indent, and we're going to say while audio.playing, end it with a colon, then press enter after the colon, it'll indent automatically, type in the word pass, and those 2 lines together say while you're playing something out of your speaker named audio, pass means don't do anything else. So now I'm going to click on save. I'm holding up my CPB next to the microphone so you can hear, and there it goes. Save again, cowbell. Save again, cowbell. So there it is. It's working. Let's modify this. Here's the challenge. The challenge is from Christopher Walken in a classic Saturday Night Live skit where he says, I gotta have more cowbell. So you want to write code to play drum cowbell.wave whenever button A is pressed. Pause, give it a shot, then we'll take a look at the code. And now we're back in Moo, and what we're going to do is we're just going to take this code and we're going to run it whenever we click on button A. So we're going to add a while true loop in here. So I'll say while true, colon, and then it will indent, and then our code to be able to check to see if button A is pressed is just if button underscore capital A dot value, colon, and this is going to be either true or false. It's going to be true if it's pressed. And then if it's true, what I'm going to do is I'm just going to move this code that I wrote up here, this 1, 2, 3, 4, 5 lines of code from wave file equals down to pass. I'm going to cut that out, Command X on the Mac, Control X on Windows, and then while I'm indented underneath the if statement right after the colon here on the next line, I'm going to paste that in. Now we can see it indented the first line, but the other stuff was all moved to the left. And Python is really particular about indentation. So what I've done is I've highlighted the stuff that didn't indent, and if I just tab over and move twice, that's going to align everything so it looks exactly like I've got here. So here's my chunk of code. I'm going to run that now. I'm going to just make sure that everything is saving okay. I'm just going to go up here and select save and notice that the asterisk is going to go away, indicating that I'm saving. And by the way, if you ever have a hard time with your code or you're wondering, hey, is my code working? The things that you can do is you can just double click on code.py, make sure that you are saving it to your CircuitPy volume here, make sure that it's named code.py all in lowercase. So I'm going to click on save and replace the file that's there. You can also click on the serial monitor, and this will show you if there are any errors. And when you click on save, your code will run. So here's my code running. I don't see any errors in here, which is great. And now if I go over and I press on button A, you got to have more cowbell. And you do. Over and over again. Nice work. Now I'm going to get rid of the serial monitor here, and let's imagine we wanted to have button B play a different sound. So there's a sound called bdzome.wave that we saved to our CircuitPlayground Bluefruit. So if you want to get button B to play and do the same thing, what I'm going to do is I'm just going to copy this whole chunk of code here. On my screen, it's from line 41 to 47. I'm going to press enter after pass, but I'm going to move all the way over again and paste it. And you can see I've just duplicated my code. But if I want button B to work, I just change A to B. And then if I go down here in my wave file, instead of saying more cowbell, I can say bd_zome.wave. And now I'm going to go up and click on the save button. And if I go ahead and try this out, well, button A works and button B. All right, I'm bringing on a funk. Nice. So you got both of those things working. Now, if we take a look at our code, though, we can see we've repeated ourselves with nearly identical blocks of code. We have in here just the drum.cowbell and the bdzome are the only things that are different between this chunk of code that starts with wave file and goes to pass, and this chunk of code that starts with wave file and goes to pass. And so you might be wondering, hey, if the only difference between these two chunks of code is just the name of the file, it would be nice if we were able to write it just once and then pass in the name of the file. Can we do that? And the good news is you can. You can create a function which is just a reusable chunk of code. And in fact, most programming languages have the ability to create functions. So what we're going to do is the first thing is we use the def statement, and the def statement here creates or allows us to define a function. Then you give the function a name. So we're going to call our function playFile because that's a pretty good name for a block of code that lets us play a file. Then after this, you can put in any parameters that you might have. Now, some functions might not have any parameters in here, but specifically what we want to do is we want to pass in a value. We'll refer to it as file name inside of our code. So instead of writing drum cowbell or bdzome in our code, we just put file name in here, and that's all we need to do. We define a function, we give it a name, we put in a parameter, and then we swap out any value in our code where we had something hard-coded in there with the parameter name. So this is how this works. In your code, whenever the statement playFile is encountered, what we're doing is we're passing in here a value that we want to use as file name. So that's drum_cowbell.wave. We run up here, we execute this chunk of code here, and any place where we see file name, that's where we're going to be using drum_cowbell.wave. Similarly, if you press on button B, well, since we call playFile and then we pass in as our value for the function here, bdzome.wave, then that's going to send that up to our playFile function. And when we run this little chunk of code at this point in time, bdzome.wave is going to be inside file name, and that's going to be the file name that we play. So functions are awesome. They allow us to use less code. There's less chance of error if you're not writing the same code over and over and over again. If we ever need to make a change, we just make it in one place. So that means easier modification of code. It helps us write programs faster because we don't need to repeat ourselves, and it makes our code easier to read. Instead of having this big, bulky chunk of code repeated twice, we have just the simple reference to playFile and name of the file. If we want to know more of the details, we can just take a look at how we defined our function. So let's give it a shot. Back in Moo, we'll divide our function, and you usually define your functions before your while true loop. So I'll type in def, which is how we define our function. Then I'll give the function a name, which is going to be play file. And then I'm going to do an open parenthesis here. And the value that we're going to play, we'll call internally just file name. Close parentheses here, and I'll put a colon in. And then after I press enter here, what I'm going to do is I'm just going to take this chunk of code that I have after my first if statement. I'm going to cut that out with a Command X on a Mac or Control X on Windows. Paste it in here, just make sure that everything is aligned so that it's just one indentation after the colon. So I'm just going to highlight everything and then Shift and Tab. That will bring everything over this way if I hold down the Shift key and press Tab. And now inside of my function that I've defined as play file here, instead of having in quotes cowbell.wave and closing quotes, I'm just going to put in file name, which is whatever I'm passing in as the value of the parameter when I call the function. I keep the RB in there in quotes. But now when I want to call my function, after I have my indentation after if a dot value colon, I'm simply going to type in play file, and notice now all of a sudden Moo knows play file is the name of the function. I'll open my parentheses here, and inside of the function I'll say quote, and it was drum underscore cowbell.wave, and then I'll close quotes like this, and this calls the function. And what I'm going to do down here under B is I'm going to do the same thing. I'm going to say play file, and I'm going to open parentheses, and I'm going to say bd underscore zome.wav, close my parentheses, and I can get rid of all the code that I've got here so we can see we're writing far less code. I'm going to click on save. Let's go over to our CPXB and see, does our code still work? Perfect! You brought on the funk. Now you know about functions. Keep at it, coder.